This sine of 1 over x term is going to trap many of you who are trying to use the LHopitals rule here, but let's go ahead and use squeeze theorem to solve this like ninjas. I'm going to start by canceling an x from the top and the bottom, and you might be wondering, is that even allowed? Because what if I divide by 0? Well, remember that for a limit, we don't have to have the function defined at x equals 0. We're just approaching it. So what I can now use is what's known as the squeeze theorem. And the idea here is to take this limit and squeeze it between two values so the answer is very obvious. And what I'm going to do is I'm going to start by writing this interval here because we know that for sine of 1 over x, or just sine of x in general, the maximum value for its output or range would be a 1 and the minimum value will be a -1. But the goal now is to manipulate this to look like what it is we're trying to solve. And so I'm going to multiply all the terms here by the absolute value of x. That way it's very clear that on the lower bound here, the value is negative. The upper bound has a positive value, and this inner part here looks a lot like what it is we're trying to prove, except we have an absolute value of x instead of just an x here. But that's okay because we know that when x approaches 0 for the limit, it must be true that a negative times the absolute value of x goes to 0, and the same thing without that negative. So with that being said, going back to this interval up here, that means that on the left it's going to 0 and on the right it's going to 0, so our answer is 0.